Japan and wonder what happened. Projectiles. Any object traveling through the air where gravity is the only force acting during flight. Computer's in the way. So the way we've defined projectiles eliminates a whole bunch of things that we think about when we think about objects flying through the air. If we're talking about projectiles, things that we are ignoring as they travel through the air are things like planes. Planes are not projectiles. They've got a big engine either on the front or on the wings, dragging them forward through the sky. Even if that engine cuts out, it's still not a projectile, because those wings that are built onto the side of planes in a perfect world generate lift. So you're getting a glider gliding to the ground effectively is what you've got there. Gliders are not considered projectiles. They are designed to lift. You can fly a really long time without an engine in a plane if you can get the sucker up there. We're also ignoring things like birds. Birds are not projectiles unless you wrap them up so that their wings can, which would be horrible, and then throw them. Now you've got a projectile. But as long as you've got something that can fly under its own power, not a projectile. Birds are no. Rockets. People often say, yes, rockets are projectiles. No, they're not. As long as that rocket motor is active, it is not a projectile. Deactivate it, all of a sudden, yeah, you've got a projectile. So when we're talking about projectiles, we're limiting it to things, oh yeah, also, I don't know why, popular one, frisbees. Frisbees, not a projectile. Because a frisbee is also designed with lift in mind. It's designed to be, you pitch the thing, it's designed to stay up. So all of these things, not projectiles. Projectiles are any object traveling through the air where gravity is the only force acting during flight. You're looking at things like arrows. Arrows are not designed to have lift. Yeah, they've got the fin at the back that stabilizes them, but those fins don't provide any lift. Things like bullets, rocks, balls, anything that doesn't inherently have a wing or generates lift. If we get more interesting, things like a railgun. If you've never seen a railgun or never had the opportunity to make a railgun, I used to judge the science fair, and there was often a kid who that was a science fair project, and they built a railgun. It's not a science project in the conventional sense, but it was always really cool. All of these things are considered projectiles. These things are not. Because once these objects have left whatever is causing them to move, the only thing acting on them at that point is gravity. And for obvious reasons, maybe they're not obvious, for reasons, we're going to ignore air resistance. We're not going to ignore lift. We're just not going to allow for it. It's not considered a projectile. We're going to ignore air resistance for all of these things, for arrows, bullets, rocks, balls, things like a railgun, because their effects are pretty minimal. What's a railgun? Have you seen the movie Transformers? What movies have you seen? A railgun is a way of launching. I mean, the reason I bring it up here is because people often confuse something like a railgun with a rocket. It's an iron rod or a tungsten rod, usually about 4 or 5 meters long, maybe as long as 20 meters long, depending on the size of your railgun. And using just electromagnetic power, which you talk about in Physics 12, you launch these projectiles. And so it's just a big slab of metal flying through the air. And we're going to look at, in 2 chapters, not the next chapter, but the chapter after, we're going to look at kinetic energy, which you may have discussed a little bit in Science 10. The amount of energy that a moving object, a massive moving object, just possesses, never mind, it doesn't need to be explosive, is pretty intense. And so these railguns are a form of weapon being developed. Put them on ships. You don't need explosives. They have no gunpowder. But it gets mentioned here because it's been asked about in the past. Those projectiles have no continuous source of power being generated to them, so I lump them in here. Someone asked about it at some point, which is why it gets lumped in here. So we've looked at a few kinds of projectiles already. When I say traveling through the air, I don't mean I'm not specifying a direction here. So we've already looked at projectiles. When we had this object, we were hanging onto the object and then it dropped. By this definition, that's a projectile. We took that object and we made it slightly more interesting in one of the examples that I gave you last week. And we took that object and instead of just dropping it, we hucked it towards the ground. That is also a projectile. Once you let it go, gravity is the only thing acting on it. All you've done is given it a little bit of initial VI. It's a little bit redundant. Initial V. Here, initial V is 0. Here, initial V is negative or downwards. So this thing is just going to hit the ground faster than this thing will. They'll accelerate at the same rate, but we've given it an initial VI. We also looked at this. We're at the bottom, and we huck the thing up. It's going to travel up. It's going to turn around. It's going to travel straight back down. We looked at that too. And if I'm not mistaken, the last thing we looked at was something like this. We've got a building, and I huck some object upwards off that building, and it lands straight down. All of these things are one-dimensional. They all exist in a vertical plane. We drop an object or we throw it down. We throw it up from the ground or we throw it up from some elevated platform and allow it to hit the ground below where we were. This is what we've already all talked about. We're going to make this far more interesting because things are more interesting when you aim them. And we're going to look at these kinds of projectiles over the next couple days. We're going to look at this one, where we've got an object launched at some kind of angle. We're going to look at what happens when you launch some object. See if I can throw this, or draw this rather. And you throw an object horizontally. So an angled projectile. We're going to look at flat projectiles, and then we're going to make it awesome. We're going to look at elevated flat projectiles. And we're going to look at the angled, elevated projectiles. All of these previous 4 had in common that we only were worrying about one direction. We only cared about up and down. Gravity was always dragging down, but each one of these was either dropped vertically, or thrown downwards or thrown up. So we're going to start angling these things. I wrote them in the wrong order. I don't know why I wrote them in this order. We're going to do them in this order. 1, 2, 3, 4, and see how this plays out. Okay, so if I were to throw an object sideways and drop an identical object at the same time, which one's going to hit the ground first? Which one's going to want to use? Let's use these two. Are there any in them? These are roughly the same size. If you're bored in other classes and you're interested in making weapons out of office supplies, I have books for that called Mini Weapons of Mass Destruction. So what I'm going to do is I'm going to take these two things, I'm going to drop one, and I'm going to throw another one sideways at the same time. Hopefully this works out. What do you think is going to happen? The one I drop gets done first, okay? How many of you agree with that assessment? Okay, we assume this to be true. Does anyone disagree with that? Okay. Well, let's... I'll do it this way. I'm going to drop one next to the desk while I push one off the desk. Hopefully when I let this one go, I let this one go at the same time. Okay, so. Were you right? You have no idea. What did it sound like? Did it sound like you were right? So I pushed one off and I dropped the other one. Initially, you guys all said, well, you will agree with me now. That when this object was dropped and this object was projected sideways, this one would hit the ground later. No, sooner. Is it sooner? This one was sooner? This one's later. Sound pretty close. But throw them further. It's my stuff. It doesn't matter if I write down things. We use with textbooks, Mr. Kiwi, we all concerned about this. So let's see if I can do this. Oh, it didn't work. No, that's not very good. Better. Are we picking up on what I'm trying to achieve? Probably wrong. Getting better. They're hitting the ground at roughly the same time, yes? The reason I'm doing this separately from the one I did on the desk I think was a lot more obvious the first time we worked basically as intended. This one and this one flew off the desk, this one landed at the same time. What I'm trying to up the ante for here is that it doesn't actually matter the speed. Because I've had students in the past who are like, oh, it was going slower. If it was going faster, then what I expected to be true would continue, right? This one would fly for so long, this one would hit the ground first, and then it would catch up eventually one day, right? I'll show you a video. See how much time we have today. Where we up this ante all the way. People don't necessarily think about guns when they think about projectiles, because often what we think about when we think about guns, the bullet just goes. You pull the trigger and the bullet flies. That's true, but if nothing catches that bullet, gravity starts to act on that bullet as soon as it leaves the barrel of the gun. Because the barrel is what's holding it up. The gun's what's holding the bullet up off the ground. As soon as it leaves, gravity starts to act. There are no wings on bullets, for those of you who have never seen a bullet. If you don't believe me, I can bring some from home. Bullets don't have wings. They will fall to the ground, just like any other of these projectiles. In fact, I listed them right there. And so what you're going to have happen is eventually that bullet's going to land, assuming it doesn't interact with anything in between. And so the Mythbusters, one of my favorite shows, put together exactly this scenario. But I do want to use as much of this time as I can. So it doesn't matter, again, whether it's thrown sideways or dropped, as long as that is flat, they're going to hit at the same time. And Adam, the not mustached guy, well, not mustached in the same way, I guess, did kind of explain it at the beginning. His explanation was, and I'm going to write it down here, gravity acts the same. Because gravity is the only thing acting, gravity acts the same on both objects, regardless of horizontal velocity. Where students often get confused is that sometimes this horizontal velocity can, depending on the design of your object, that horizontal velocity can add lift. In the case of a projectile, that's just not happening. So, you've got we'll draw out what happened, and this will probably take us to the bell. You've got an initial object sitting here. You've got another initial object punted sideways. The drop distance is the same for both of these. Let's go like this. We'll draw some ground here. The drop distance for both of these is the same. Doesn't matter what it is, let's call it D. The mass for these two objects doesn't have to be the same. I tried to prove that to you several days ago. It doesn't. I had two different size books. I had a book and a piece of paper. It doesn't matter what the masses of these two objects are. That has no bearing on the speed at which it will fall. Acceleration due to gravity is constant. For this one, the VI equals 0. Acceleration is equal to negative 9.8 meters per second squared. We don't know what the final velocity is. Doesn't really matter. This thing is going to have some time it takes to hit the ground. This object is slightly different. Because this one is just being dropped, it's like we've done, everything's in the vertical plane here. This one is being bumped sideways. So we do have to acknowledge the two-dimensionalness of this particular problem. I'm hoping I've convinced you that it doesn't matter that this thing's being thrown sideways. It's still going to hit the ground at the same time. Because that's true, what that means is that the horizontal and vertical portions of this problem are independent. And we will finish this tomorrow. We will pick up exactly here. Have yourselves a great day. We'll see you later.